This is the example of the cross pollination, means uh, example for the interdisciplinary research. So I think electronic person knows the turbo codes by electronics expert during the 1993. So this is the error correcting code, है ना, which is also known as the turbo codes, and this is nowadays widely used in the satellite and high speed networks. Also, somebody knows the Viterbi algorithm in the dynamic programming. And dynamic programming is what? Dynamic programming is the formulation. Based on that, computer scientist can solve the problem with the help of the dynamic programming. So once you see that there is a problems, and in the problems, once you are solving the problems, and whenever you are approaching step by step or stage by stage, then it may happen that in the next stage you may be using the solution of the previous one. So you don't require to recompute again, because you have already computed, and you need to restore in some lookup table. And whenever you want to use that kind of information, you just go to the lookup table and don't require to recompute it, and you just use. And this is known as overlapping substructure. So if you have the problem like overlapping substructures, then you can go for the dynamic programming. And once you go for the dynamic programming, you know that this is the method widely used in the computer scientist. There are many computer scientists are using dynamic programming for finding the optimized solution of the optimization problem. And once you go for the dynamic programming, then you know that the solution based on the dynamic programming is accurate, because dynamic programming itself find out the itself analyze the options, various options, and if it sees that out of the number of available options, if it sees that what are the benefits of the options, and it will pick up the options that has the most beneficial. So it is based on the principle of dynamic programming. The question is that, and say that Viterbi has given the algorithm for the dynamic programming, which is also known Viterbi's algorithm. And this is if you have the idea about the Markov models or hidden Markov model, or then you know that there is a need for finding out the hidden state. So you have the hidden states, you have the sequence of hidden states, like you are speaking something, and if you go for the speech translation or pronunciation, then once you are going to speak, and you have several phonemes, and according to the phonemes you are visiting the states of the finite automata. You have the automata, means you have the hidden states, but state is not clear actually. And you have the sequence, you are having the observed sequence. Like, see the examples. If somebody has the two pockets, or somebody has the pocket, and in the pocket he is having the two coins, one is the biased one and one is the fair coins, and he is tossing the coins. And you know that once you toss the coin, then there is a chance that there is a equal probability that head and tail will come with the equal probability of 0.5. You know, if the coin is fair, then there is a chance that somebody is tossing the coin, you may get the tail, or the same chances are there also, you may get the head if the coin is fair. But see that the person is having the, in the pocket, person is having the two coins, and he tossed the coins, put it on the pocket, again pick up and toss the coins. So you believe that, okay, you are he's having the, he's tossing the coins, but sometimes he tossing the biased coins, and sometimes he is tossing the fair coin. So see that if you are observing the some sequence, but you what you see that you are observing some sequence like head or tail. You are given the sequence. So somebody has given you the sequence that okay, this person has tossed the coins 100 times, and out of the 100 times the coin toss, this is the sequence of the outcome. So sometimes you have observed that tail, sometimes head, tail, like the things. And somebody asks you that, okay, this is the observed sequence, and I want to know that when this person tossed the fair coin and when he tossed the biased coin. Means you need to determine the state of that hidden morphomer. And means you have the observed sequence, and based of the observed sequence you need to determine what is the path actually, and that path actually leads to the proper pronunciation in the speech once you are going for the natural language processing. Then in this case, or in hidden, so you have the hidden states. So you need to predict the what is the sequence of the states person has visited. So Viterbi algorithm based on the dynamic programming is widely used for observing the hidden uh, states in the natural language processing. So he see that he is the person from the electronics background, but he did the contribution in the computer also. This is one of the great example of the interdisciplinary kind of research. And I think everyone knows the Alan Turing. Those who are from the computer background, actually, they knows the Alan Turing. Anybody knows the
Yes.
Alan Turing?
Yes, sir. He invented Turing test, which coined the artificial intelligence term for the first time, and also he played a very important role in breaking the Enigma code
Hmm.
during World War II.
Yes. Anybody else from the computer?
So Alan Turing machine.
Hmm. What is the contribution made by the Alan Turing in our computer? Any computer scientist knows?
Sir, Turing machine.
Turing machine. Good.
Sir, whatever we are studied here,
Hmm.
it is possible because of Sir Alan Turing.
Okay. So see, Alan Turing was born in 1912, and he died at very young age, 1954, and I think around 42 years of age, and he died. But see that even in this small life, he did lot of remarkable contributions. So Alan Turing studied at the Cambridge University. He was doing the BS MA course at the Cambridge University. This is the Cambridge University where your Alan Turing studied. And Alan Turing actually, he is the mathematician. He is not the computer person. He is a mathematician actually. And see that he has, during 1936, Alan Turing has given the abstract model of computation, and that will become the basis of your computations. In fact, your Alan Turing has invented the Turing machine, and Turing machine is actually he was having the thought about the human computer. So just like the human beings, we have the different states of mind. You know that. So at the beginning of this course, you have some different state of mind. At the end of this course, you will have some different state of mind. At this time, you have some different state of mind. At the yesterday, you might having the different state of mind. So as long as you are getting the information, your state of mind is going to change. And this is the computation actually. Your mind is going to do the computation. So your machine is going to do the computation just like the human brain. So human mind, how we are going to do the computation? We have the information, and your brain is changing from one state to the other state. Every time it receives some new information, it is going to change the state. It is going to transit the state, and this is transition means this is the computation happens. So, but see that we have the infinite states, and our brain is going to change from one state to the other state while it is going for the computations. So a Turing machine is actually that time, during the 1936, Alan Turing has thought about the human computer. So he says that how human beings is going to compute. But actually, whatever Turing machine we are going to use, that is the restricted version of the human computer. In that restricted version, instead of having the infinite state of mind, since we cannot represent the infinite states of mind, we cannot store in our desktop, means we cannot store in the hard disk. If you have the infinite states, you need to remember the infinite state. For remembering the infinite state, you should have the storage also. So we need to perform the same thing. Just our human brain has the infinite state of mind, but we need to perform the same job with the finite states. So that is the Turing machine actually, and Turing machine is actually the modern basis of your modern computer. The modern computer becomes powerful only after the Turing machine, and it is believed that Turing machine is believed that this is the much powerful model of computation. And there is no more, even say 1930 Turing machine was invented during the 1936, and today is what, 2021. So more than 90-80 years have been passed, and even the Turing machine is still more powerful model of computation. There is no more powerful model of computation exists. And Alonzo Church, who was the guide of Alan Turing, he was made the statement that any problem, if you can solve with the help of pencil and paper, any problems if you can solve, or any problem a team of person can solve, or any problem if some machine can solve, then your Turing machine can also solve the same problems. Means if you can solve the problems, then Turing machine can also solve the problem. So once you are actually, whenever you are doing the research, and once you are finding some kind of formulation, actually you are going to determine that Turing machine actually, and people are confused about the Turing machine and algorithm. So algorithm and Turing machine is same. Once I say that this is the Turing machine for my case, this is for finding the solution of this problem, it means I am saying that this is the algorithm for finding the solution of this problem. So algorithm and Turing machine both are interchangeably. Turing machine is nothing, it is not a physical machine, this is the algorithm. You are going to proceed for finding the solution. And it is believed that if a person can solve the problems, a team can solve the problems, or machine can solve the problem, then your Turing machine can also solve the problems. So that's why this was the abstract model of computation actually. Everything in computer is abstraction actually. So I believe that I'm talking to you, but actually I'm talking with my computer, or I'm observing my camera actually. I'm not talking to you. This is the abstraction actually. So computer is the mathematical model of computation. So after the Turing machine actually, our computer becomes much powerful. During 1973, and our computer becomes much powerful. So see that it is only because of this notable person, and this is not only one contribution. During the Second World War, he has given the coding system for decoding the text, and during that time actually he saved the millions of lives at that time. Later on, he has conducted the uh, test which is known as the Turing test for the machine intelligence. So that Turing test was conducted by the Alan Turing, and it was very simple test. Means you are sitting in a room, you are sitting outside of a room, and in the room you have two partition. In one partition, you kept one machine, and in other partition there is a human being. And you are outside of the room, and you are communicating to the machine and the human being also. But you cannot see that which partition contains the human being and which partition contains the machine. You are interrogating, and on interrogation you are getting the replies, and once you are getting the replies, and for 5 minutes if you are not able to recognize which partition contains the machine and which partition contains the human being, then it is believed that machine has passes the Turing test. And this was the very simple test conducted during during 1950s by the Alan Turing. And at that time, natural language processing was not much strong. So only actually at that time, this is the kind of pattern matching job. So a lot of criticizations comes for this test. Actually, people say that okay, this is not the true test for the machine intelligence, as this is the just job of the pattern matching. So like if I don't know the Chinese, but if somebody is there and he is speaking with the Chinese and he's not seeing me, I am in the different room, and other side persons are Chinese person and he is going to speak in the Chinese. But I am having the dictionary, Chinese dictionary. So whatever text he is going to supply, I am just going to match with my dictionary, okay? And whatever written against that, I am going to supply this. And person says that okay, person could not understand that okay, whether I know Chinese or not. He believed that okay, I also know the Chinese. But actually this what I am going to do, I am just going to do the pattern matching. So I have the dictionary, whatever symbol person is going to sending me, I am just matching the pattern, and whatever written against that pattern, I am just sending back. So this kind of pattern matching job at that time done by by the Turing test. But nowadays, for truly machine intelligence, we need real-time performance, vision, machine visions, and everything we need. But that was the beginning of the artificial intelligence. And later on, John Mauchly has coined the word artificial intelligence. So artificial intelligence was also credited to the Alan Turing. So question is that people is from the mathematics background, but see that he has done the contribution in the computer, and this is the importance that we should work on the different fields, and that's why computer will become the mathematical models of the computation. So the person who is good at the mathematics, he will also good at the computer actually. So and these are the examples. That's why always you should have the practice for go for the interdisciplinary research. So you don't get rid from the interdisciplinary area. You should, but for solving the problem in that area, first you need to study about that area so that you can understand the problems about on that area, and later you can apply your knowledge base of your own area for solving the problems. Now this is also one example for the interdisciplinary research, and frequency hopping was discovered by the actress actually, Hedy Lamarr. So frequency hopping communication system, electronics persons may know, that was intended to control torpedoes without the enemy being able to discover what frequency was being used. Once Hedy Lamarr and composer works together and was able to determine the radio controlled torpedoes, and later on actually they have taken the patents, and I think later on they have given to the Navy for that case. So question is that when you go for the Wikipedia of this lady Lamarr, then you will come to know that she is the actress. People cannot believe that actress can do this kind of scientific contributions. So ideas can come any time. So this is also one examples for the interdisciplinary research. Interdisciplinary research always encouraged nowadays. See, we have the field which is known as the bioinformatics. And in bioinformatics, what is basically there? There is a actually in bioinformatics, you have to deal with the DNA actually, because actually the whole thing is DNA in the human body. Actually, what DNA is the main thing in the human body. According to the DNA, protein synthesis is done. So once you go for the central dogma of molecular biology, then you will come to know that protein synthesis is done by the DNA. DNA guides protein synthesis. Means according to your DNA, you will have this chain of proteins. So you will have the and chain of amino acid actually, and these amino acids actually has some amino acids are fruitful, some are have some kind of drawbacks according to the chain you have, and everybody has some different chains of the amino acid, and according to the chain you are growing, and your your hairstyle, your way of working, way of communications, everything is different. So DNA, with the help of from the DNA actually, protein synthesis is done. So the question is that if you are from the computer scientist, and whenever you work on the DNA is what? It is the chemical actually, which is found in the cell nucleus of any wood. So cell nucleus contains the DNA in the form of the chromatin. So once you want to work on the DNA, so see that nowadays there are situations when you are going to match the DNA, and people, biologists or life scientists are going to lab for matching the DNA, and every time they go for the laboratory, they take much time. So actually these life scientists think that if the advancement of computer happen, means nowadays computer become more powerful, and with the help of this powerful machines can we solve our problems. So once you work on that area, then you are dealing with the DNA. And for the computer scientist, what is DNA? Actually, DNA is not a chemical for us. It is just for the string of the characters. So in the DNA, you have the four residues: adenine, cytosine, thymine, and guanine. Then your DNA is the combination of these four residues. And these four, according to these four residues, according to the sequence of these residues, you have the sequence of amino acids. So see that if you if you stretch one DNA, then it goes several kilometers. The length of the DNA is very large. So see that in the one DNA you will have 3 billion bases. In if you have the DNA, if you store the DNA in your hard disk, which is the string of characters, then you will have the 1 billion bases, and 1 billion means 100 crore. So say that 1 billion bases you have. So see the length of this DNA, and you have written the algorithm for string matching. Now can you write the algorithm for the matching the two DNAs? And once you go for matching the two DNAs, and this may be simple, but somewhat more difficult task is you can align the DNA so that you can find out the similarity between the two DNAs, and you can predict the ancestor of based on that. So if you have the 2, 3 DNA, you can easily come to know that which one is the ancestor of this DNA. So that is the application. But for doing this kind of application, you need lot of time in the laboratory. And biologist wants to solve this problem with the help of the computer system, but they cannot write the algorithm. So they are looking at the computer scientist for solving this problem. So see that everybody for solving this kind of problems, mathematician is equally important, life scientist is equally important, computer scientist is equally important. So I am telling that you may believe that okay, why I should solve the problems of the I am from the computer, why I should go for the biologist problem, why should I work on the DNA, and why should work on that protein structure like this. So see that we are having the knowledge and we are applying our knowledge to simplify the problems for the interdisciplinary field. And believe me that according to your knowledge base, you will have the contribution. Once you go for the interdisciplinary research, then whatever is your area, you have some different unique knowledge about that. You don't know that whether your knowledge may work on that field, and if it works, then it will solve the problems for millions of people. Nowadays, you know that these are the pandemic situations, and COVID-19 situations is there, and people are finding the actually whatever why this COVID becomes severe. Actually, the situation becomes very serious is because it is attacking on your DNA. So gene expression is going to change. So that's why whatever vaccines are going to discover, actually, they are focusing on the protein level. So see that for discovering this kind of vaccines or for creating the drugs or creating the medicine drug cocktail, you can say that, which is the personalized one, which that can be suitable for the particular person, we need the first model of computation. And for solving such kind of problems, scientists from the different backgrounds should come together to solve this kind of problem. So that's why now people are looking at the interdisciplinary research, and now in the outside of India also they are promoting the interdisciplinary research. So you don't think that if you are from the computer background or if you are from the electronics background or if you are from the mechanical or mathematics, you are solving the your problems only. You should think about the other problems also. You don't, you may you don't know, you may give the good contribution in that area. So always try during your PhD work, try to solve your problem, but whatever is your, you have obtained your formulation, whatever obtained you have in the novel approach you might have got, that novel approach you can apply for the interdisciplinary field and solve the cross across the your area. Means you have to go for the interdisciplinary area and find out the problems people are facing and you can solve it. So so see that Dr. Grace Murray Hopper, this is the pioneer in the computer scientist, but see that PhD in the mathematics. So she was having the PhD in mathematics, but she has discovered the COBOL programming language. So see, people from the different background, they have discovered the computer programming language. So from 1959 to 61, Hopper led to the team that invented the COBOL, Common Business Oriented Language. And this COBOL language was much famous earlier. Nowadays, in our course, in the BE course, we have not the COBOL, but we studied this COBOL programming language. This is the first user-friendly business computer software program. So Dr. Grace Murray Hopper, born in the New York, December 1906, and he died in Virginia in 1992. So see that the person from different background has given the remarkable contributions. So see the importance of interdisciplinary research. So these are some examples for just for your encouragement to see that you should not look at only your field. Means you should have the broaden your area. You keep your eye open and find out the problems people are facing, and that problem may be from the different background. There is no issue. You always think that can you apply your knowledge base area, knowledge of your area to solve that problem. So now people are promoting interdisciplinary research, and one benefit for doing the interdisciplinary research you will get immediately is that publication. So there is a fast publication. Once you go for the interdisciplinary research, you will have the fast publications. So if you work on your own field, the field may be much matured, and for giving insight in that field, you need to work very hard. But if you go for the interdisciplinary research, then it is very, there is a good chance that okay, that your paper will be published very soon, and that will be counted in your PhD work. So because interdisciplinary work, people encourage the interdisciplinary work because you have the background in your area, you have the background for the computer, and you know how to write the algorithms. Someone is a mathematician, he knows that okay, how to prove the theorems and how to represent the model, how in the mathematically. So you are representing some formulation mathematically, you have some model which, so these are the knowledge. And if you are solving, say, biology, if you are solving the problem for the life scientist, and you know that the life scientist, the students generally, the students who are in the biology background, they are weak in the mathematics, they are not good at the mathematics. And you are, if you are good at the mathematics, you are the mathematician, or if you are the computer scientist, and if you can give some mathematical formulation of their laboratory work, then the problem will be, this is very interesting, it will become very interesting for them, and the paper will be published. Like nowadays there is a trend that you have to go for the analysis part. Whenever you are writing your algorithm, you have to go for the analysis also. Just writing the algorithm will not work. You have to prove that your algorithm works correctly for all possible legal inputs. So you need to first, you need to prove, you have, say, if you have come up with some sort of algorithm and you say that, okay, this is my area, this is, sorry, this is my formulation, this is my algorithm for solving that problem. People say, yes, this is the algorithm. First, so what you need actually, once you submit this thing to the forum for the review purpose, then your reviewer will first try to see that how you have proved that whatever method you have given, how you have proved that this method works correctly for every kind possible legal inputs. So first you need to say prove that, you need to write the mathematical theorems for, and then you may use the mathematical induction for proving that, okay, your whatever your algorithm you have designed, your algorithm, this algorithm is working for all possible legal inputs. So this is one thing. People are nowadays people are interested to know that whether this is legally correct or not. Your algorithm is legally correct or not. And once it is correct, then if I have many algorithms, how I can use your algorithm? What is the benefit of your algorithm? So you tell the benefit of your algorithm. How you can tell the benefit? By going for the analysis, and you have to provide the theoretical analysis for that cases. So what I have seen that the person from the electronics background in our I they have interrupted me some at some point. Why they have interrupted me? Because they were writing the papers, and in that paper they have mentioned some sort of algorithm for the solutions. And since the trend changed for the analysis, they was feeling the difficulty to analyze the algorithm, as people believe that, okay, this is the part of computer. So actually analysis is part of every field. So believe me that if you are from the electronic person, if you have analyzed, you have written the algorithm, and if you have proved that, okay, your algorithm is working correctly for every possible input, and later on you have given the analysis of your algorithm, you have provided the theoretical analysis that, okay, your algorithm has this kind of benefit, and among the existing algorithm, this is the theoretical analysis, and my algorithm has benefit like this, and in this particular situation, this algorithm is benefit as compared with the existing one. And then there is a fair chance that your reviewer will accept your paper. Question is this: if you are having the ideas about the different field, so you should also learn the analysis part. Once you are going for the research, even you are from the electronics background, but you need to learn that how to analyze your algorithm. And once you have the analysis, how to represent the analysis with the in the form of the asymptotic notation, means the notation people are using for analyzing the algorithm. So this thing also you need to learn. And see, if I am the computer person and I'm solving the problem from the mechanical person people, and I have written the algorithm and I have provided the theoretical analysis, and then it will become very interesting for the mechanical person that, okay, I have written the algorithm, and I have also have given the theoretical justification of my algorithms, and I have given the graphs and number of things, and I have visualized the data, and it will become the very interesting one, and your paper will get uh, accepted because the communicability of your paper become strong. So once you have the knowledge of several background, so you will have the much scope, you will have the much room for communication of your work. Communicating the idea is very, very important. So how efficiently you are going to communicate, it is also very, very important. So once you have the different knowledge of the different background, then it will be very easy for the communication. So nowadays interdisciplinary, learning the interdisciplinary field is very, very important, as there is people at the beginning level, when you were in the undergraduate level, or when you were in the PG master level course you might have done. At that time you might be feeling that okay, mathematics is not important, or electronics is not important, or some biology is not important. Why should I study the DNA? Why should I have the concept of the protein? Why should I go for the protein structure prediction and all that thing? So see, this at that time you might have thinking like this, but now once you are going to do the research, at the research level all fields are going to merge, and you don't know the which field knowledge will help support in your research work. If you are having the knowledge of some different fields, that knowledge may support for your research. So that's why at the level of research everything is very important. So during the research level field, the barrier of subject, barrier of field is totally disappears, and you become only the investigator, you become only the scientist. So that's why don't hesitate to learn the interdisciplinary areas, because once you have the data, once you have the information about the interdisciplinary area, you will come to know the problems in those areas, and you will have the solution, because you can formulate that solution in different way the traditional people are going to give. The biologists are giving the solution and computer scientist is giving the solution totally different. Mathematician gives the solution totally different. Electrical person gives the solution that is totally different, because you have the different kind of knowledge base, and we don't know that which kind of knowledge will work on this kind of some kind of field. So that's why people are promoting for the interdisciplinary research. So you can also give equal importance for the interdisciplinary research. We are not greedy for solving the small problems. Actually, we are worried about solving the problem for which we have the large input size. For a small input size, every problem has some kind of solutions. We are worried about the problems for which we have the large input. In the real life, we have the millions of inputs we need to supply, and for finding the solution of such kind of input is our target. And we are greedy for finding the solution in the reasonable time. See that very simple problem of searching becomes very difficult once the search space becomes large. So this is the search space means what? You are searching for particular algorithm. What scientists believe that? Scientists believe that we have the search space, and in this search space all possible solutions are there, and based on the present knowledge base we are not able to find out that particular solution, but in future we may be able to find out that particular solution, and the problem which is very difficult at present time may be solved at the later stage. And why this is the intuition scientists believe, and means they believe that in the search space of the solutions we have some algorithm available that will terminate in some reasonable amount of time, and we need actually at the present time we are not able to find out that, but we have to work to find out that particular algorithm that will terminate in reasonable amount of time for this kind of problems.